Greetings, and welcome to this episode in the series of videos on Lidar with ArcGIS Pro. This series is brought to you by AmericaView in partnership with the College of Natural Resources and Environment at Virginia Tech, the Virginia Cooperative Extension, and GeoTed UAS. I'm Cherie Aukland, and I'll be your guide. Prior chapters omitted a discussion of surface constraints, which specify processing or classification limitations. Surface constraints are created using vector feature classes that represent a feature in the area covered by the LiDAR point cloud, such as trees or buildings. They can be included when creating a last dataset, or they can be added later. We need some vector files to use for surface constraints. See the Chapter 7 video on locating LiDAR data for specifics on getting to and navigating the Mesa County, Colorado GIS download site. Go to Data Download, and under Hydrography, download the lakes shapefile. Under Property, download the BLM properties and building footprints shapefiles. Unzip them to your project folder for this chapter. Begin with a new map and add the Mesa County last dataset created in Chapter 14, where we added the additional tiles to the last dataset. Add the three shapefiles, building footprints, BLM, and lakes, and change the symbology on the three vectors so the footprints are distinct. Here we have one lake and several buildings within the footprints of the LiDAR tiles. We'll use the lakes and building footprints to create surface constraints. The BLM is strictly reference information, and you can turn off the base map if you like. Since the study area is not all of Mesa County, not all of the buildings and lakes in Mesa County are needed. Using interactive selection, we'll select only those buildings and lakes within the footprint of the LiDAR point cloud. To make this easier, change the Contents view to List by Selection. On the Map tab, choose the Select tool. Drag from the upper left corner to the lower right corner of the 6 LiDAR tiles. You should see 1 lake and 6 buildings as selected features and contents. Note this differs from the book, as the data I'm using is more recent. In the book they mention 5 building footprints. Now let's create 2 new feature classes. One for the lake and one for the selected buildings. Let's head back to List by Drawing Order. Right-click on Lakes, go to Data, Export Features. Name the output feature class Surface Cons _ lakes, and leave the defaults for all of the other parameters. And go ahead and click on OK. And let's repeat the process for the Building Footprints feature class. Here you see the 2 new feature classes and contents. Let's remove the original shapefiles and clear the selection. To verify that the only features in the new feature classes are 6 buildings and 1 lake, let's check the attribute table for each feature class. So here we see 6 buildings and just 1 lake. These 2 feature classes are now limited to those features we're interested in and can now be used as surface constraints. Before adding any constraints, understanding the limitations are important. Go to Catalog View, and let's right-click on the last data set, open its properties, and choose Surface Constraints. None are currently listed, so let's add. Click on Add, and navigate to where the new Surface Constraints Building Footprints feature class is. Let's review these 2 additional parameters. Selecting the down arrow next to Height Source, you'll see the options in the drop-down list are fields in the attribute table. The surface constraint is normally set to one of the fields in the attribute table as a height variable, or elevation above sea level. Choose Building Top Elevation here. When creating a DEM, eliminating the points representing buildings is appropriate, because the top of the building is not normally on the ground. Now look at the surface type options. Each one of these parameters determines how the surface constraint will be used during geoprocessing and any subsequent operations. Notice that most of the options start with the words hard or soft. Visually, both options create the same image, but hard designates some type of interruption in the surface. Examples of linear features could be a stream, a ridgeline, or the edge of a structure like a building. For a polygon, examples could include building footprints or edges of a water body. The choice of hard or soft as a constraint depends on the project for which you are processing the data. Each of these surface type options is discussed in detail in your text. Please refer to your text for a complete discussion. Now click on Add. So the building surface constraints are added to the last data set. And let's go ahead and close this dialog box. Let's go back to the Map tab and open the properties of the last data set. Let's view the surface constraints. Here you see the feature class we just added. In order to apply the surface constraint to a geoprocessing tool, you'll have to check this box, but we won't do that just now. And we'll close this box. So what if the attribute table doesn't have a field or a useful field upon which to base a constraint? For example, the buildings file from Mesa County contains the building height, but the height is in meters, whereas the LiDAR data is in feet. Let's zoom in to one of these buildings in this little set right here. I've got a bookmark for it. Be sure to check that Visible Layers is selected in the Explore dropdown. The building top elevation and the z-value for the points in the point cloud are very different, meters versus feet. In this instance, the building height should be converted to feet. We can do this by adding a field, then calculating the new field as elevation in feet. To add a field, either open the attribute table if you closed it before, or just go to Surface Cons Buildings, and select the Field Add button. I'm going to make this a little bit bigger so you can see what we're doing. For the field name, I'm going to call it BLD top elev underscore feet. We want the data type to be double. And we want the number format to be numeric with 2 decimal places. And be sure to save your new field. You can close the Fields window if you want to. Now let's go ahead and add values to the new field. You may have to scroll right to see the new field. They usually are added at the very end. Right-click your new field and choose Calculate Field. We're going to build the expression type, building top elevation, times, clicking in here, 3.281, which is the conversion factor for meters to feet, and click on Apply. So we can see building top elevation underscore feet has been populated, so go ahead and click on OK. So now let's go ahead and compare this new attribute with a point in the point cloud. The building top elevation is still just a bit different, but whether the building has a peaked roof is not known. This value could represent an average of the varying elevations, the elevation at the peak or the elevation of the usable space. The building height values should be verified prior to adding as a surface constraint. A second way to create a height or elevation field for the buildings is actually using the point cloud. Assume that the building elevation field did not exist at all in the original Mesa County buildings shapefile. Let's close this pop-up. Make sure you have the Mesa County last dataset selected and choose the Data tab in the last dataset layer group. Click the down arrow under Statistics and choose Point Statistics over Polygon. Here we see the last point statistics by area geoprocessing tool. Choose the Surface Cons Buildings feature class from the drop-down menu. The output property are the new fields that will be added to the attribute table of the Surface Cons Buildings feature class. For this example, we're going to check all of the output properties. And we'll run the tool. Checking the attribute table, you now see all of the new fields, the maximum value of all points contained within the boundaries of each building polygon, the minimum value, the average, how many points were used, and the standard deviation. ArcGIS Pro automatically recognized the differing z-values, feet versus meter, and added the new fields as meters, the units of the building feature class. Now that we have appropriate fields in the Surface Constraints feature class, Let's update the surface constraint field in the last data set. Go to Catalog View and open the properties of the Mesa County last data set. Go to Surface Constraints, select the feature class present and remove it. Add the Surface Cons buildings again, and choose the new field, Building Top Elevation Feet, for the height source. Go ahead and add it, and click on OK. Now, what if a water body is the feature used for a surface constraint, and the attributes do not include a height or a water depth value? Let's go back to the Map tab, and I'm going to close out these tables, and zoom to the lakes layer. The lake does have some points within its boundaries. As done with buildings, values could be extracted, but water depth is difficult to determine from a LiDAR point cloud because clear or deep water does absorb LiDAR, and the points displayed within the polygon could be reflected from surface features or debris or sediment. Let's compare the LiDAR point cloud to a Google Earth image of the lake. Some features are clearly visible, including some vegetation. A field could be added if the water depth values were known. According to the Colorado Birding Trail, the Cheney Reservoir is a shallow irrigation lake, and no depth documentation is provided. So how to proceed with no depth or elevation information? To eliminate points within the boundaries of the lake from the analysis, use a hard erase and none for the height source. So from the Catalog View, opening Surface Constraints, we can add the lakes with a height source of none and the surface type of hard erase. And OK. Add and OK. As a final note, once surface constraints have been added to a last data set, they need not be removed if they're not going to be used in analysis or processing. When surface constraints are to be applied, select the constraint to be used by checking its checkbox before running any geoprocessing tools. Of course, you have to remember to turn them off too. The next chapter will compare the results when surface constraints are applied and when they're not.